and welcome everyone to the SOFLUX webinar. I'm really happy today to have Simon Josey presenting on a clearer view of Southern Ocean air-sea interactions. And I'll let you take it away, Simon. Thank you for being here.
Okay, thank you. Thanks for the invitation. That's quite an ambitious title, I realise, and hopefully we're taking some steps. This is a modified version of a talk I gave in London a few months ago. I'm going to skip some bits in the interest of time, but let's just give a bit of an overview. So I'll start by talking a little bit about sampling issues, which we have to remember all the time in the Southern Ocean. I then want to talk a bit about what I call a heat flux asymmetry in the Southern Ocean, and it was something which really became more apparent to me following some work of Veronica Tamsit a few years ago, so I will give her the credit. But I think it's potentially a useful constraint on flux data sets and coupled models, and one which we haven't used so far. So that will be one theme of my talk. I shall then go on to talk about using observations to fill some of the gaps, focusing on moorings, and then talking a bit about some of the exciting campaigns, and in particular the one that Seb's leading at the moment, a sail drone campaign. I may or may not talk about marginal ice zone stuff. I don't really have much new on that at the moment, although I am thinking about it. And there's also some model-based insights, and also this work that I've talked about that Polina has led that I'd like to bring in for discussion. And those slides just show one of the surface flux moorings and also ERA 5 fields, which I'll come on into more detail in a little while. Now, how do I advance my slides? Because that didn't work. Well, that didn't work. That's done something. Right, okay, let's go forward. I'm probably just clicking it advances the slide. Okay, so I had on here, just to familiarize people, I think most people here, I can't see everybody at the moment, but I think most people are fluxy type people and will know what I'm talking about.
I'm not sure if the slide's advanced for us.
Can you see it's the same slide, but in that, yeah, did that advance?
Okay, that's advancing, yeah. So yeah, this says Southern Ocean sampling problem.
Not sure how I go back now, but let's just, oh, I can see how to do it, it's on there, right. Okay. So it's the same as the first one, but it has some magnitudes for the components of the flux terms, just in case people aren't familiar. And as we know, as I'm sure you know, in the annual mean, even though there's dispersion between the different flux data sets, they pretty much show that the Southern Ocean is a region in the annual mean, which has marginal heat gain or heat loss, depending on exactly where you look. And these are example values for the SOFLUX mooring site south of Tasmania. So obviously we've got our large solar gain signal, and that's balanced by latent heat loss, long wave loss, and a sensible heat flux. That's just a general introductory point I wanted to make. This figure I always show, even though it's getting a bit long in the tooth now. We might have to come up with a new figure, Sarah and Seb, to keep people interested. This was something from a paper or a commentary in EOS a few years ago. And I've seen lots of versions of this figure over the years. It's basically saying that if you look in the Southern Ocean and you rely on traditional ship of opportunity and well, also research ship observations, any ship observations, it's very hard to get, well, there is no sampling. The sampling is extremely low. This shows all of the observations from ships which would enable you to determine the latent heat flux over a 5-year period in July, so in the depths of winter. So obviously there's the ice edge has extended a bit, but even so, north of that ice edge, in the regions we're really interested in, we've got huge data deserts. Look at the Pacific there. There's nothing in that region in July in the 5-year period we're interested in. And so we've been very fortunate in many ways in the last 10 years. At first, we had the Southern Ocean Flux Station deployed in 2010, and then we had the Ocean Observatories Initiative, and I'll come back to SOFs in a minute. That's still in the water on its 11th or 12th deployment now. Ocean Observatories Initiative mooring was in the water for several years, can't remember exactly how many, from 2015, and both of those moorings have yielded very interesting and useful results. But before coming to that, I want to talk about the heat exchange in general, and we'd ask this question, it's the one we all want to know, what is the surface heat exchange in the Southern Ocean? So You can go to reanalyses, obviously, and they assimilate whatever observations we have. There's very little at the surface ocean in terms of air temperature and humidity, just those scattered ship observations. Satellite SST will be pretty good, and satellite winds, if they're assimilated, should be pretty good. But there's still a lot of uncertainty in these fields and big dispersion between products. The thing which is interesting, which is kind of recognized, is if you look in this region, let me highlight it actually. If you look in this Atlantic Indian sector and contrast it with the Pacific sector at the same latitude, here we have the net heat gain into the ocean. And over this side, we've got heat loss from the ocean. And that's driven partly by the fact that because of the currents, major currents dipping south in this part of the Southern Ocean, we're bringing warmer SST values, and that's enabling a stronger heat loss. But that's not the sole story. I think this, if we were to take a large-scale average of the heat flux in this region and a large-scale average, a spatial average of the heat flux in this region, then the contrast between the two is something which we might hope to use as a constraint on different reanalysis products. We might help to use as a constraint, perhaps more interestingly, on coupled models. We will know how important the Southern Ocean is in the climate system and in projections going forward. It troubles me a lot that across CMIP, for example, we really have no idea how well they're representing the heat exchange in this region. And rather than, or in addition to seeing evaluations of CMIP models which show you lots of maps, let's get some useful large-scale integral measure of the quality of those models. And I'm suggesting that this may be one. And why am I suggesting that? Well, I'll come on to the moorings in a minute. So let's just talk about the cause of the asymmetry. This shows the turbulent heat flux and the radiative heat flux side by side. This is very uniform zonally, as you'd expect the radiative heat flux. This one, you can start to see the asymmetry. This is the sum of the latent and the sensible. And if you take off the zonal mean, you could see it even better. And you can see that the strong asymmetry is occurring in the turbulent heat flux. Here's this blue pattern in the Pacific, saying stronger than normal heat loss, and we've got weaker than normal heat loss here. And so these two moorings, which we have already, are very interesting, the AOI site there and the Southern Ocean Flux Station, but they're both in this band, this region, where we have stronger than normal heat exchange. And so I know there have been plans, ambitious plans, to perhaps put 10 moorings in a ring around the Southern Ocean. That was a Chinese plan a few years ago. Perhaps that's still happening. But I think what we can start to advocate, from my perspective anyway, is if we had one more mooring and we could put one in this particular characteristic region of heat gain, it would be very useful because it would enable us to start to tie down the fluxes on either side of this asymmetry, and hence better formulate a large-scale constraint. So that was kind of the pitch I was making, if you like, to spice up the talk when I gave it a few months ago. And I hope it makes sense to people here, and we can talk about that at the end. I'll move on from that. I probably go through this next bit quite quickly because it's just an overview of the sorts of advances we've made with the two moorings. I've said that bit already about when they've been deployed. So the Southern Ocean Flux Station, this just shows that the towers are the same pretty much on both moorings, I think. And also I want to give a massive amount of credit right now to the people who actually put these moorings out, to Eric Schultz in particular, to Bob Weller, of course, for leading this for many years. I've played no part at any point in my career in putting these moorings out. And so I've been entirely reliant on other people's efforts, and that's something that needs to be said. But the data from these moorings, you're typically getting wind speed measurements from a sonic anemometer, short and long wave measurements, temperature, humidity, pressure, some measure of precipitation, but it's debatable how useful that is. But we had those sort of measurements then for the very first time back in 2010. This is data from 2010, and it shows you the rich amount of information in here. So this is a time series which appeared in the paper that I contributed to, that Eric led, where we had the first deployment over virtually an entire year of a high quality flux mooring in the Southern Ocean. And we were able to quantify for the first time what a heat exchange was in that year, and it was a small heat loss by the ocean, as you can see in this table here. But these were near annual figures because we missed the last so many days, 10 days of the year. So it would actually be slightly stronger than this. And this just shows the data averaged up at daily and monthly timescales. Okay, I'm not going to dwell on that anymore in the interest of time, but I will show you this one. So Eric gave me this slide back in late April or early May, and it just makes the point that we now have 10, or I think there's now on deployment 11 deployments of this mooring. So it's a fantastic effort by Eric to get this repeat deployment of this mooring. This shows just one example field, the incoming shortwave radiation. So it's now a fantastic decade-long data set, obviously with gaps. So whereas the figures I was showing you just now were just this very first year, we're now in position to write a very good paper analysing that, and Eric's going to lead that. Hopefully I'll be able to contribute to that as well. The other mooring, the Ocean Observatories Initiative mooring was here, and I was very fortunate to be able to get involved in the study that, well, Sarah was involved, Veronica Tamsit, a very good student of theirs, Sarah Ogle, led this work where we did quantify the observations from this mooring and started to look at the annual cycle at this location. So you can read that one. And then Veronica, and that's some of the details from that one. And then Veronica built on that work. And I think this is the one I want to focus on, yes. So now a nice paper which came out a couple of years ago was for the first time comparing the measurements at two sites in the Southern Ocean Flux Station and OOI. And interestingly, we found two different regimes for strong heat loss at the site. Now that's important because these are strong subantarctic mode water formation locations. And you can have what you would expect, which is if you get cold, dry air coming up from the southwest, you get strong heat loss at both sites. So this is a coordinated mode water formation between the two sites. But we were also able, by looking at the time series from the different moorings where they overlapped, to identify another mode of variability where we only had strong heat loss at the soft site. And in this situation, you had this feature where we had a circulation of air approaching the soft site from the west to northwest, but it had originated to the south. So that was cold and dry, where the parallel flow of air at this site was from the north and then to the west, from the west. And that was a warm condition. So we can have uncoordinated heat loss under these conditions. And so subantarctic mode water formation at two sites being uncoordinated as well. So that was quite a nice result, and it's discussed at length in that paper. So I'm going to show 2 or 3 more slides, and I'm going to stop. I'll be about halfway through at that point, but it'd be nice to have some questions in the middle, maybe, if that's okay with people. So this is now moving on to a work I'm involved in courtesy of Seb and JB Saleh, who leads this big European project, EU project called SOCHIC, Southern Ocean Carbon and Heat, essentially, and all sorts of stuff going on there with lots of field campaigns, lots of model analysis, and so on, lots of people involved. Part of that is to look at, to do some sail drone deployments. So here's a sail drone, and there are now 2 sail drones in the water moving towards this location. And that will enable us, amongst other things, to look at correlation scales in more detail for the heat loss. And that's something that's extremely important, because a big question, which actually Sergey has put to me many times in the past, and is one we all worry about, is if we're using reanalysis data and the resolution of that reanalysis, well, it was 1 or 2 degrees, maybe it's 1/4 of a degree now. How representative is the reanalysis data when you're comparing it against mooring measurements? We need to make that transition from the grid cell scale to the point scale. And also there's a question about correlations between different locations, whether the atmospheric models are accurately representing the atmospheric processes, or whether those are getting smoothed out because of grid scale coarsening as well, if you like. And this figure here then just shows a very first stab I did at looking at this issue. And this was using ERA 5 hourly data and asking at the sort of the mission, the central mission site for these sail drone, for these sail drones, asking what the correlation between this site and elsewhere was within ERA 5. So at each point on this map, you're seeing the simultaneous correlation of the latent heat flux with points elsewhere. And you can see a difference in scales depending on whether you're looking east-west or north-south. And there is a plan, I think, under this sail drone campaign to have the second sail drone move north-south along this line, not this far, but to try and get a handle on these scales, these correlation values from high quality observations, and then use that to test how well the reanalyses are doing. That takes me nicely into this slide, which I got hold of yesterday. So it's quite exciting because I'm on this project and Seb's put me onto this where you can see the sail drone update every day. They're both, there's one sail drone here, one sail drone there. They're en route to this target location, which I think they reach at the beginning of August pretty much. And then there'll be a month or two, possibly 3, I don't think that long, where we can do all sorts of interesting co-located measurements with them. And I started to do some initial analysis on this as well, thinking about, again, using ERA 5 hourly data. This top plot just shows time series of ERA 5 hourly heat loss at this primary sail drone site in blue, and then offsetting it by a certain amount in green. This is an extreme amount. This is 40 degrees east, and this is where we thought we'd be comparing with the Carioca buoy, but that may not be possible anymore. But the interesting thing is, if you start looking at lagged correlation rather than simultaneous correlation, and each of these lines, so there's this line here is the exact co-located value, so obviously it has a correlation of 1 at time 0, and then that correlation falls away on a certain time scale. But at each of these subsequent points is 5 degrees further east from the site, so 5 east, 10 east, 15 east, and now you can start to see a peak at a lag time. So I don't know what that is, 8 hours and then 12 hours or something like that. That's the sort of thing we can usefully use to test how well the reanalyses do at capturing in terms of capturing the key processes. Okay. At that point,
Simon,
yeah,
sorry to interrupt.
good point to stop. Ask me questions, please.
Can you elaborate a bit on this bottom plot where this lag correlations are presented? So
yes,
we have time lag actually.
Yeah, so this is a plot I produced an hour ago, in fact, as recent work. So what we see here is, imagine the top 2 time series, okay? So imagine that one is at 54 south, 0 east, so it is, that's the blue one. But instead of this second one being at 40 east, imagine it's at 5 east, okay? Then you can calculate a correlation between those time series at lag 0. You can do it at lag 1 hour, 2 hours, 3 hours, and so on. That's what you're seeing on these ones. So this is the lag. This is the correlation at 5 degrees east, 54 south, 5 degrees east, relative to 54 south, 0 east. And of course, you expect a delayed peak in the correlation because that gives you an advection time for the major cyclonic systems coming through. And then you're seeing the peak driven by the peak in wind speed, etc. Subsequently.
We have 2 locations, in fact, so deviated from each other by roughly I think 1,500 kilometers or something, and we correlate them with different time lags, right?
Yes.
On the same latitude.
On the same latitude, exactly.
So, okay, sorry.
That's fine. So the purpose of this plot is to tell you, it's just to indicate the sort of analysis that we can do, or that is relevant to these sail drones. I think in general, I mean, this particular campaign is obviously going to be limited in what it can do, but it's showing us the way ahead in the next few years for getting a handle on a new aspect of reanalysis and coupled model performance. We've not worried very much about correlation scales in the past. We've tended to look at the integrated heat flux and say, well, how well does that heat flux from the model compare against this heat flux from a mooring or another model or another reanalysis or whatever. But I think it's also important to worry about the small scales in the model and seeing how well they correspond to observations, particularly when you're using those models, those reanalysis fields then to force high resolution ocean models, for example, and you're worried about eddy properties and eddies being extremely important in the Southern Ocean. And we know that the air-sea interaction can change markedly on very small scales over eddies. So there's lots of questions here. Has anybody else got a question at this point on anything I've said?
Yes, Simon, please. I want to follow up the Sergey's question.
Yeah.
It's about, if you take a look on the, for example, spectra of the time lag gain here, would you see some peak on the synoptic period, like 5 to 7 days or something like that?
Yes, I mean, I think that's the general thinking there. So in my head, I wonder if, say, I thought to myself, well, is this interesting or not? Because we know these systems are going around at that latitude. We can track them using satellite observations, as you and many people have done. So perhaps that's not the most interesting thing. Perhaps the more interesting thing is if you're going down to just scales of a couple of degrees. So in this sort of region here, in the first 5 to 10 degrees, and at that resolution, because of the blocky nature of the reanalyses, because of the grid scale limitations, it could be that they are not representing very well those correlations, and then that can have an impact when you're using high resolution fields to force ocean models, and then that can have an impact on eddies. And we know that eddies are very important in Southern Ocean dynamics and so on. There's lots of arguments there. So that's kind of what I'm thinking about as being the question which is of interest. But your point is correct. Yeah, it will register the synoptic timescale. Yeah.
Okay. Thank you.
I can take the follow-up as well. An interesting thing, Simon, might be if you take, for instance, okay, with a resolution of ERA 5 of about 30 kilometers or so, so you can take as many as about 80 points, special points, at every moment, actually, between Greenwich and 40 East. And of an interest would be probably to look on special correlation functions.
Yes.
Yeah, and then okay to consider them in conjunction with this temporal correlation. Exactly. If you place it on like a 2D diagram, you can even have a hint on the phase velocity or something.
Exactly.
To retrieve whether this was a cyclone or was something. Something. Okay, I would not argue for a stationary wave, but something different, you know.
Yeah, exactly that. I think it's very interesting, and also looking at the difference between east-west spatial correlation scales and north-south, particularly in the presence of fronts, is another interesting question. So yeah, hand in hand, looking at the temporal and spatial correlations. So let's hope the mission carries on and it's a success. I mean, it will carry on, but let's just see. Now I'm going to change direction slightly and talk about some results we've got in Southampton, looking at the high-res coupled models, looking at various high-res coupled models. So this is work that my colleague Jeremy Grist has led. So these are just a couple of slides to give you an indication of some stuff we're doing right now. And one question we have, this is again model resolution dependence, because we've got various runs of the HADGEM3 model, either with a high resolution atmosphere and a high resolution ocean. So that's HH, or a high resolution atmosphere and a medium ocean. And then there's various other combinations, high resolution atmosphere and low resolution ocean. And so there's been a lot of work, not just in the UK, but with other models elsewhere around the globe, looking at resolution dependence of many things, for example, Atlantic Ocean heat transport, stuff like that. What we found, or what Jeremy found is interesting, is that the increase in ocean resolution leads to a reduction in the SST and the latent heat loss, which I think is ocean driven. So what you can is clearer in the SST. So this is now the difference between control runs with the high resolution ocean, the HH run, and the medium resolution ocean, and we can see a cooling of the SST in a band of the Southern Ocean, particularly in this Atlantic Indian sector. And although it's early days, this appears to be related to the latent heat flux. In fact, I need to point out that these maps are offset. It's a bit annoying like this. This is a recent figure. So I just want to show this as an illustration of some work we're doing looking at model resolution. But another aspect of this, which I think is a little bit clearer, hopefully, is when you come to look at projections, this is now 2030 to 2050, minus 1950 to 1970. So with the same difference in time periods, you get a different degree of warming depending on whether you've got a high resolution ocean or a medium resolution ocean. And you take the difference, you can see more warming when you move from a 1/4 degree ocean to a 12th degree ocean. And this comes back to the point I was making earlier about having confidence in CMIP runs or projections, because those models, as we know, are at best a 1/4 degree, and many of them are significantly coarser resolution in the ocean. And you can see in this bottom plot, which shows the zonally averaged SST, but depending on whether you're working with a medium resolution ocean in blue or a high resolution ocean in red, you can get differences of a degree or so, or approaching a degree, in the projected warming in the future. And that's interesting. I read this paper. I'm not sure if you're on it, Sarah, but I know Lynn was on it, wasn't she? It was published by She at the end of last year.
I'm not on that one, but it's interesting.
Yeah, and it's a nice analysis of lots of different observational data sets and models, which in my head basically shows, I can't really do it on here, but a warming north of the subantarctic front. So I don't know, roughly here, probably something like that. And the argument is that you've got this warming, and that's changing the meridional density gradient, and that's leading to an acceleration of the zonal flow. They're quite careful not to say, I think there's an acceleration of the ACC, because that's more difficult to say, but an acceleration of the zonal flow. So this is, I'm sure, going to provoke a lot of other studies as well. But one thing that's key is if you're doing model analyses, you need to worry about model resolution when you're looking at projected temperature, and that could influence this degree of zonal acceleration that you're going to see. Kind of made that point in a roundabout way, but hopefully it's clear. And then a third point on this work we're doing now, these are lots of different coupled models, and it's a classic sort of plot which you do where you plot the zonal mean heat flux. This is the latent heat flux in the Indian Ocean, the Atlantic Ocean, and the Pacific, and these are now differences with respect to ERA 5. So perhaps you have some confidence in ERA 5. It's a starting point. We have to be cautious with that assumption. But if you look at ERA 5 and take that as your comparison, what we find is that the differences with respect to ERA 5 vary on what sector of the Southern Ocean you're in. So in the Indian Ocean, at 40 to 60 south, in that sector of the Southern Ocean, and in the Atlantic, you see clear differences with respect to ERA 5. I'm not necessarily going to call them biases. They may be biases if ERA 5 is accurate. But if you look in the Pacific sector, then we're seeing that that the various coupled models are in agreement with ERA 5. So my point here is we have to worry about saying in general models are accurate to a certain level in the Southern Ocean. This is indicating that there are significant biases or differences depending on where you are in the Southern Ocean. And that comes back to the point I made earlier, where we can try and get some, if we can get an observational constraint, which is asymmetry based between the Indo-Atlantic and the Pacific sectors, that could be a very useful way of constraining these models. Okay. Right. So here is a shameless attempt at an advert, because recently I got a paper published in the for some North Atlantic work in this Nature and Comms Earth and Environment journal. I encourage you to go and read it, obviously. And Sergey and Co know about it already. What I'm trying to say, I'm not going to go into the details of this figure. It's a bit complicated to explain right now, But what this study is trying to do is look at the relative contributions of surface heat flux and ocean heat transport to changes in the heat content of the mixed layer. And it challenges the view that the ocean, that's primarily controlled by the atmosphere at interannual timescales. We've shown that for the subpolar North Atlantic using observations and models, but we could extend this framework now and do similar things in the Southern Ocean. That's a challenge which we're hoping to take on. Okay, enough of that one. Yes, I think I've probably got about 5 minutes left. Is that right, Sarah, before you want me to stop, or 10, or where are we?
Yeah, it's up to you.
Okay.
We want to make sure there's time for discussion, but we've had some already.
Okay, so just to make the point again, so the other big question, I should say that I'm going to be writing a lot of this up for a review article in a Royal Society journal. All the speakers have to do that. So I'm going to touch on a lot of these questions and some new results. But the big question for a long time for me has been how are these different aspects of Southern Ocean forcing changing with time? The heat flux on the left I've talked about briefly just now. I think it's quite uncertain. This figure will look quite different depending on which data set you look at. It's a difference between the last 35 years, essentially, in the preceding 35 years using era 5. Interestingly, it shows that the heat exchange, if you have confidence in it, is increasing. So let me say that again. The heat loss is getting stronger. That's what blue shows. The heat loss is getting stronger in this region. And I think this includes the region that is referred to in the She paper as being north of the subantarctic front. So that indicates that it's not local changes in the heat exchange which are driving the warming there. It must be, to my mind anyway, some sort of a vectored signal. But what I want to talk about a bit more is the wind stress. And I have a particular what position on wind stress changes, which I'll elaborate on. This shows actually wind speed change. And here we can see a strengthening of the winds, which a lot of people have talked about in many papers in wind stress as well in the Southern Ocean. So how well do we know that this wind stress is changing, both in its strength and in its location? We had a figure. This is now 10 years old. Sergey will recognize this. This was in AR5. And it was the one figure I actually prepared from scratch. I think it's quite nice. And it built on work by Swart and Fife, different Swart, and showed this long-term trend in the wind stress in various reanalyses. So one question is that continuing? And is there an associated southward displacement, which many people have claimed? So I haven't got a new figure myself on this, but I found this paper by a Chinese group led by Deng in atmospheric research, and just came out recently. This shows the black line is era 5. So now we've got 1980 through to nearly 2020, and we can see the strength of the Southern Hemisphere, Southern, it says SHW, but it is Southern Ocean winds. I just noticed that. The strength of the Southern Ocean wind is increasing, the black line. The various historical runs of the models are also increasing, but it's a relatively small signal. It's about, that's their quoted value is 0.07 meters per second per decade, compared with a mean signal of 10 meters per second. So we're looking at a 1% change per decade in the wind speed strength, which isn't huge. And the reason I say that is because many of these studies, these idealized model studies, ramp up the wind speeds or wind stress by a huge amount, the sort of doubling or even tripling the wind speed or wind stress in the studies. I don't think that's really supportable, and I understand that sometimes you need to do that in order to get a model response. So there is some strengthening of the winds. I think that's fairly clear, but I think there's very little or zero evidence for a southward displacement. And I'm laboring that point because I continually read, but it's established that the Southern Ocean winds are strengthening and moving southwards. And it's kind of lazy, well, yeah, I'll say that word. It's kind of lazy reporting sometimes. I think the evidence for this from wind moving southward just doesn't exist. Maybe people will shoot me down on that one. I'd like them to if they want to. I'm not going to show, okay, so this just shows how these winds continue to change in these model studies, but that's not my point in the talk today, so I'm going to move on from that. And point out another figure, which I also found when I was trying to start. Yeah, go on, yeah.
Simon, sorry, if I may ask a question, please, for the previous slide. About the positioning, how did the position of the wind speeds were taken, and what does this mean? This means that there is a polar deflection, and the major wind speeds are the area of maximum wind speeds is locating further and further from the pole, or what does it mean?
Yes, okay. I've got another slide in a couple of minutes which might answer that question. I'm not sure, but I'll come to that in a second. And I can't remember off the top of my head exactly how they defined it in this paper, but it is a circumpolar measure. So I think the winds, what's been done is at each longitude, you search for the maximum in the wind in a particular year, and then you take the average of all those values over all the longitudes, and then you do that in successive years, and that's how you get the time series.
I see.
Which is
so this is like the changes in the position of the maximum wind speeds around the pole. Like they are moving in the very severe scenario. They are moving out from the pole. I see.
They're moving. Yes. So okay, I'll talk about this slide for just one second. If you can see my cursor. So the point is, yes. So if you look at the location and you take the strongest scenario, the 585. Then right out at 2100, they have moved south, but they've only moved, even in that incredibly strong scenario over 100 years, they've moved south by about 1.5 degrees, which is not a massive displacement. It is a displacement. And in the other ones, depending on where you look, there's a smaller change in the massive reduction in CO2 scenarios. They're actually encouraged. Well, I don't know if that's encouraging or not. They appear to be moving back equatorward. There's an equatorward shift. Yes, okay, so you can make of that what you will. Moving on, so trend signals. So there's another paper. This is why I'm a bit concerned about a lot of this. This is quite a nice paper which is really focusing on the Antarctic, and it has lots of stations over ice and a few in islands and so stuff like that. That's the majority of this paper. Which was in Journal of Climate, but it also just usefully has maps of the trend in parts of the Southern Ocean, if you like, the southern half of the Southern Ocean, for various different reanalyses, which will be familiar: ERA interim, ERA 5, MERA, JRA. The point I'm making is, depending on which plot you look at, the local trend in the wind speed can be positive or negative. And there's very few regions where it's significant. If you look at JRA, for example, there's no significant trend in wind speed over much of this southern half of the Southern Ocean. So the general idea that the winds are strengthening there, or they're moving south, and so we'll see a strengthening in this region, isn't really supported in these reanalyses. That's the point I'm trying to make there. And then this one I think is also important. So a nice paper. This was, England was on this, Sengupta and Goyal, who I don't know, they led it. This makes a point nicely that many of you are aware of, that coupled models tend to have the position of the maximum in the wind stress, or the wind speed, if that's what we're looking at here, too far north. So we go back to CMIP 5. This is the band of the maximum in wind speed. It's quite a long way north of what you get with ERA 5, which you can see here. And so my understanding is, when these models are spun up or something, or whatever, in the early phases, then you see this strong southward displacement. That's why people think that the Southern Ocean winds have moved south. But really, it's an artifact of the fact that the winds were too far to the north in the first place, and the model's adjusting. Please, again, correct me on that if I've misunderstood the situation, because that's not my field. Situations improved with CMIP 6, so you can now say, oh, in this sector, we've got a pretty good agreement. And over here and there as well. But we still have, CMIP 6 is still quite a long way off over a good chunk of the Southern Ocean from south of Australia through across a large chunk of the Pacific. That difference between model and observations, if you like, if that's what you want to call ERA 5, is that's a 1 or 2 degrees. It's the difference is as large as the signal, which some people are claiming is the southward displacement. So there's still a big worry there. That's the point I'm trying to make. Now, oh, good. Right, I can't quite remember what I've got. Right, I think this is going to be my last slide, and that would leave 15 minutes. Yeah. So this is the paper. So I had not seen this paper before, I have to say, and not up with the literature there enough in the Southern Ocean. But it's the paper which Polina led, and with Sergey and Natalia and other people as well, I think. This is the plot which caused a lot of discussion in London, and Joe Ellen was putting up and saying, so let's do this plot first. So this plot shows, it's a quantile plot, that's right. And we've got the reanalysis on the y-axis and the scatterometer, the quick scat values on the x-axis. And this is for a 4-month period in 2004. I haven't written that on. Oh, yes, I have. It's up here for June, July, August, September of 2004. And so if I understand, this is certainly how it was reported in Joe Allen's talk, you get the particular point in the distribution, and the scatterometer is saying the winds are 10 meters per second, whereas the reanalyses are all saying they're only 4 meters per second or 5 meters per second. That's a huge difference. And at face value, unless I've misunderstood it, this is saying that across the board and getting worse as you move to higher wind speeds, the reanalyses are the winds are much weaker than the scatterometer winds. The other aspect of this paper, which I thought is very interesting, is when you look at mesocyclones. So there's a lot of tracking stuff in here. Oh, sorry, I didn't mean to do that. This is the region they were able to track. So essentially, they picked out, I think, 1,400 or occasions or satellite plots of a cloud field in 2004, tracked the mesocyclones, looked at the winds in the mesocyclones, and showed that some reanalyses were able to capture the mesocyclone winds pretty well, because they compared well with the, that's nearly on the 1-to-1 line. But other reanalyses, JRA and ERA 5, did particularly badly at capturing those mesocyclones. That's really important, because the mesocyclones can generate.
Sorry, I have to interrupt you. It's not the ERA 5, it's ERA interim. That's why it's,
okay. Thank you. Thanks for that.
The discrepancy is so high because of the ERA interim. Yeah.
Thank you. Yeah, good. I'll come back to that in a minute when we have questions. So I've got a question on that. So anyway, so following this meeting, I didn't do any more thinking about the Southern Ocean, because I was thinking about the North Atlantic, but with this talk, I've come right back to it. And I want to know, at the end of the day, what this figure really means and how bad news it is for the reanalyses. And I think that's something we'll come back to in questions in a minute. So let me just skip on from there and just show you that I've been doing marginal isoclone work, and I'm going to skip over all of that. That was work with Lisa and you, and come to some conclusions, and then perhaps we'll go back to that plot I was talking about just now. So conclusions, we still have the massive undersampling issue in the Southern Ocean. I've been arguing that there is this zonal asymmetry in the net heat flux, and I think it can provide a really useful constraint, and one we should be employing. In order for it to be really, really useful, we've got to get a mooring in the water somewhere, either in the Atlantic sector or in the Indian sector. I've moved it from the earlier slide to make the point that it can be over here as well. But we need one more. And I won't labor this bit again. This was a bit about the coupled model stuff. I'll leave you with that top slide in your mind, and the need to get a third mooring in the water, which I think is the most important part of this talk. Okay, thank you very much.
Thank you, Simon. Let's open things up for questions. This was great.
Thank you. See a couple of hands up. Oh no, they're clapping hands.
Sorry, may I start? Sorry.
Yeah, go ahead.
Yeah,
and people can use the reactions to raise their hand.
I have quite a few questions. My first is with respect to this actually Pacific Indian Atlantic pattern which you
Yes.
have started with. Did you look into how it is, whether it's persistent or not, actually, going through years? Is it repeatedly appearing every year, or it looks like just probably a pattern, just changing?
Yes, this is a very good question.
Like a dipole or something.
Yeah, the answer is no. I've not looked at that, but yes, it's probably the next thing I plan to do on this, and it will certainly be in the paper which comes out of it. So it's that very question: is this a persistent asymmetry from year to year, irrespective of what ENSO is doing and what the state that SAM is in, etc., or is it something which changes from year to year? That's an interesting research topic in its own right. I don't know the answer to that question at present, Sergey, but I'll have it soon. And it also comes back to whatever conclusions we have on that point, are they robust across different reanalyses as well, and couple models? Yeah, yeah, it could easily change from year to year, but as it's driven, as I understand it, so Veronica took it as far as saying the asymmetry arose because of the path of the ACC, and that the SST values were that much warmer, more southern latitudes in the Pacific sector. So if it really is an SST-driven thing and is less sensitive to the atmospheric variability, then you might expect it to be more constant from year to year, but it wouldn't be that sensitive to the state of the atmosphere. So that would be an interesting thing to find out.
Well, my other question is regarding actually this very nice plot with cross correlations and an attempt to associate changes. Yeah.
Let me get back to it. This sort of thing, and the one a couple on as well. Yeah. What's the question?
No, if you scroll back a few times more, yes, exactly. Yeah. If you look onto, and there were some previous plots actually on the previous slides. Indeed, very likely cyclones are clearly associated with propagating cyclones are clearly associated with this identified time lags and potentially space lags. Yeah. And just to make a point, not so much of questions, that Natasha is still there. Because
yes, she's here. Yes, I'm here. I can hear you.
You're here. Because we made a work with Natalia some 2018 or 2019 or so in Master Earth Review. We tried to associate cyclones with flux patterns actually, or better to say flux patterns with particular types of cyclones, looking on whether they're propagating or whether they're stationary. We did this only in the North Atlantic, but I think a good idea, probably a proposition for joint work, if you like, since we have this database of all cyclones from our reanalysis also in the Southern Ocean, it might be interesting actually to look onto this way of association.
Okay.
The Southern Ocean, indeed. That's I will ask Natasha probably to send this paper to Simon.
Yeah, please do. That's a very interesting suggestion, Sergey. Yeah. I hadn't thought of that.
And, just okay, on the top of this, we decided there was a paper in even 2009, 2010. It was a dual paper actually, part 1, part 2, by a lady from what's called, forgot her name, Yuan, I think. Yuan. Yes, Yuan, exactly. And there's her colleague who is male. I remember his male, I forgot his name. And they argued, and they argued that particularly in the Southern Ocean, strong fluxes, turbulent fluxes directed from the ocean to the atmosphere, they are not associated exactly with cyclones, but rather with cyclone, anti-cyclone interaction zones where actually there's a strong wind and actually advection of the cold air and somehow just a strong gradient between the. And this might be another hint actually on whether it's propagating or whether it's stationary, you know, because our conclusion with Natasha was in that master's review paper that you need to have a strong flux, you need necessarily have a anticyclone at the back actually, at the back of the cyclone. And that was kind of, so this is good thing actually to look more precisely probably with cyclonic data which Natasha has, so we can.
Yeah, I really like the sound of that. I think that's very interesting. And I actually did some work.
This is extremely interesting actually, this correlation functions. And again, I encourage you to make also these correlations in space.
Yes, definitely.
It might give a hint actually on how to deal with cyclones.
Yeah. It'll be very interesting to talk to you in the months ahead about a lot of this stuff.
Natasha can also comment upon this if you want.
Yeah.
Yep. There was one figure illustrating exactly cyclone high and low pressure interaction system on your slide, Simon. One of the next slides, I guess. When you were arguing. Yeah. No.
This one.
No.
I'm not sure which figure you meant.
No, I guess it was
or
it was before. There was a high-low pressure system and heat loss. No. Oh yeah, that one.
That one.
Yes.
That one. Yeah.
That's exactly. You have a cold, dry air as the cold air outbreaks in the rear part of the cyclone. So, yeah. And it was like, only 10% of the heat loss in the Southern Ocean is happening into the cyclones, but the rest is outside.
That's very interesting. Okay. And that's from papers, from research that you've done, you're saying, or is this in that earlier papers?
Yeah, I'll send you all the references.
Yeah, lovely. That'd be really interesting. Because I was aware of the work by, there's a Norwegian guy, Lucas Papritz. Do you know?
Papritz, yeah, I know Lucas, yeah.
So he did some work on freshwater fluxes and association with cyclones a few years ago, which I found very interesting. And I should say, so I haven't been, I mean, the North Atlantic is my main field of research. That's what I'm normally doing. And I did a paper with Helen Dacre at Reading. She has a cyclone climatology for the subpolar gyre. And we asked the question, how much of the very strong heat loss in the winter of 2013-14 was due to cyclonic systems? And the answer was about 50% of it occurred during the passage of strong cyclonic systems. So I've got some familiarity with doing that through her work, but it'd be lovely to do something for the Southern Ocean as well.
Yeah. I'll be happy to cooperate in that.
Great. Thank you.
Yeah.
Well, I have a quick question. You've made a pitch for a third mooring.
Yeah, good.
And as a SOFLUX effort a couple of years ago, we did an analysis where we said, where would you put these hypothetical 10 moorings? And I just wondered how this third site compares with what went in the Way et al. Paper for the lineup of the next moorings.
Okay, so I haven't, I should, what I'll do for the next time I give this talk is show the slide from your paper there, and any of the ones which you had in this region, which you had for different reasons of variability, etc., any of those sites would be good. We really don't want it, and we also have to think a little bit. This is the 50-year mean or something like that. You might have to try and get perhaps a more recent plot, the last decade or two of the heat loss, something like that. But it's not, this argument about the asymmetry isn't tied to a particular site. It's quite a broad region. So if JB manages to get funding for a Kerguelen mooring, which I can't remember exactly where Kerguelen is, but somewhere over here, that would be fine as well. But I think, tying it to your paper, Lay, did you say was the first author?
I think it's Way, but I'm going to get it wrong.
Okay.
I think that paper explored many different cost functions, and it sort of laid out an approach that could be rerun with exactly the right data fields for what you're doing. But it might not be the right answer, but it was a strategy for optimizing how to
Yeah.
explain the most variance possible, if that's the right cost
Yes, I
function.
remember. Yeah, it's very interesting. Yeah.
Yeah.
I'll certainly, so I'm going to try and I can write what I want in this review paper, so I can put a third site in, and I'll do it in the context of the way paper, and it'd be good to chat to you, Sarah, about that.
Yeah, I'm happy to do that.
Good.
Are there other questions?
I have a question.
Great, you're there. Fantastic.
I'm still here, so thanks so much for a very interesting, provocative talk. Of course, the third site question. So obviously that's very interesting, and the way paper did a lot to help figure that out. I'm just curious to think. So if you had to technologically ignore mooring and swap it out with autonomous platforms, because there might be some data cost benefit.
Yeah.
Would you have any strong feelings about that in particular, or you're just if you're thinking of what can be measured with well, now we have the sail drones going in again into the Southern Ocean. They seem to be able to handle strong wave and wind conditions. How might that? Do you have any immediate thoughts on that?
The kind of glib answer is, ask me again in about 3 or 4 months' time when we've had the sail drone deployments, and I get a good handle on what the data are showing us and how accurate they are. But the longer answer, of course, is yes. From everything you've said and from what I've read, the platforms can give us measurements at certain times. I think what we want is an annual mean, ideally. I think the value in that, well, maybe it is. I suppose maybe not. Maybe the asymmetry, you could characterize it with a summer mean or a winter mean. I don't know. Do you need a full annual mean? It's a number we like to have, and I'm not sure what those platforms can give us that number as yet. They can't be deployed for a year in the same location. Or am I wrong?
No, I mean, indeed, there'll be probably significant wear and tear on sensors and stuff like that. And but if you imagined some small fleets replacing one another 3 to 4 times a year, since they autonomously sail, from the ports themselves these days, the sail drones, for example, they don't need a ship, they don't need winter cruises and things like that necessarily.
And of course, you already have your circumpolar sail drone data set. Have I got that right?
Indeed.
Yeah.
Yes, indeed. So I think the longest data set in there is there's 3 sail drones, 3 missions. I think the longest is 5. No, it must be longer than that. 6, 7 months. There were lots of data issues. Sail drones hitting icebergs and losing anemometers and getting stuck in the ice and all sorts of things. But yeah, if you thought of a single site, being changed out 3 or 4 times a year.
Now I understand. Yeah, sorry, I was being a bit slow. So you're not talking about the same platform being in the why not? You could do that, and you have them sitting alongside each other for a few days and get the cross calibration, etc. And what site would you? So if we had it looking at that screen now, which I think you can see, that is whereabouts. It's probably fairly close to the one we're at now. That would be a good site. You can see it smack in the middle of that region of heat gain. So we'll have seen how easy it is to do. Takes a month to get down there, doesn't it, from Cape Town?
They're struggling a little bit upwind at the moment. So, that site is about spot on, I would say, where we're going. 54 south, 0 east. Yeah,
well, it looks good. Yeah.
Just a provocative thought,
have it as an ambition. Yeah, I mean, it should be doable. I think for this season, how long will they be there in the water once they get there before the mission ends? Is it 2 months? Is it 1 month?
It's going to be about 3 to 4 months.
Brilliant. Okay, so we could, so that would give us essentially a season. This between seasons, I suppose, slightly, but we can use that then as some useful measure straight away of how the reanalyses are doing. And SOFLUX is currently in the water, as I understand it, from Eric. So we could, at the same time, be getting the sort of opposite measure of the asymmetry, if you like, on the other side of the Southern Ocean. So yeah, some interesting things to explore there. Yeah.
Yeah, that would be very interesting. Cool.
So we are past the end of an hour, and there's one hand up. So maybe we can take one more quick question and then we'll need to wrap up.
Okay, that's the question from me, and my hand is. Hi again. You mentioned the buoyancy flux and the wind stress in the Southern Ocean on the
Tasha, can you speak up, please?
Can you hear me?
Yes, yeah, I can hear you.
Okay. You've mentioned the buoyancy flux and the wind stress on one of the slides. Are you aware of any of studies that would relate these anomalies of the turbulent heat flux or this ozonality of the turbulent heat flux in the Southern Ocean to the anomalies maybe of the buoyancy flux or to what is happening in the ocean?
Right. I think your question is saying that the wind stress and the buoyancy loss are not independent, and you need to consider them at the same time, and the joint studies of those two effects. Is that correct?
No. Yeah, maybe like that, but I was asking in generally, do you know any of the studies that would relate ozonality of the net turbulent heat flux to the processes in the ocean and maybe through the buoyancy flux or?
Oh, I think you're saying, what about the ocean response then?
Oh yes, yeah, the ocean response.
Well, with the mooring, I mean, I haven't talked about this at all. But there was lots of analysis of the AOI measurements in the surface layers of the ocean. What's the best paper on that, Sarah? I mean, that's work that did Veronica publish it, or is it Ivana?
Yeah, I'm not sure.
So Ivana,
I'm not sure which paper. There are not too many on the AOI mooring. So
what I know is, and again,
yeah.
I should know this a bit better, but Ivana Cherevsky and Andrew Myers talked a lot about well, heat content may not be the right word, but the mode water layer characteristics, I think, in response to buoyancy forcing and wind forcing. And that paper did appear. It has a bit.
I think so.
So yeah, I can point you in the direction of that paper if you're following this.
Yeah.
It was about 10 years ago in GPO with Lynn Toddy, I guess. Exactly on the 2 years data set in the Southern Ocean.
Okay.
But there's been some more recent work too.
Probably there were follow-ups, simply I didn't follow them.
Yeah.
Great.
Okay. Well, I think we need to wrap up. This was great, and I'm sure there will be lots more discussion by email. This has stimulated a really fantastic discussion and a lot of good thought.
I'd just like to say briefly, thank you very much for joining, because you're never sure when you give a seminar, particularly in these days, whether it's going to be good or bad. This has been fascinating for me. I'm really grateful to my Russian colleagues in particular for being able to join. And I'm really grateful, Sarah, Seb, everybody here. And I've learned a lot. So thank you.
Thank you very much, Simon. Can I send your presentation around?
You can have it, yeah. But I think that's all okay.
Yeah, and SOFLUX will always post the webinars.
It's recorded anyway. Yeah.
Provided the speaker's willing. So
absolutely happy. It'll all be shared. Yeah.
So, thank you very much.
Okay. Thanks.
Bye, everybody.
Thanks, Simon.
Lovely to see you again, and everybody.
Bye. Thank you.
Thank you. Thank you.